Alright guys, so let's start the lab. So where's our plan here? Our plan is to know how to install a container and how to go inside, what's the difference between virtual machine and a container. What's the difference that I may have mentioned before, but container is much lighter and the virtual machine is a bit heavier, and I'm just trying to grab some of the information. So that information we talked about. I'm just on the other screen right now, and I'm trying to grab a slide that I created to talk about this. So Dockers and containers both really actually have the same concept here when it comes to Dockers, containers and Dockers. So if we go ahead and try to talk about virtual machines versus containers, also there's Kubernetes here that we're going to be talking about. So Kubernetes is also the other part of the problem. And yeah, normally developers use that. So if you're not a developer, then it would still be very interesting to know this stuff. But if you're not a developer, so you would not be really working a lot on the containers and Docker and Kubernetes. So still, whatever I could come up with, I'm trying to do that, but can't go much more in depth than what I'm already doing here. Guys, give me a second here. Resuming. Okay, so what we were talking about was that, did we resume? Yeah. First thing, and second thing, why containers? Why would we want to bother going to containers and Kubernetes? Well, the thing is that containers are widely being used by companies where developers have been hired in the company, and the developers are developing applications. They are trying to test out the applications, and well, if you want to, it's like DevOps, really. That first you develop the application, then you make a workflow of that application, and a continuous development is going on, continuous deployment is going on. So programmers and developers really are they do interact a lot with this containers and Kubernetes. So we may have discussed that a lot in Azure as well. And thing is that pretty much nothing changed there. In Azure, yes, we may have gone for actually I guess Windows machine, but here we're gonna go for Linux, and we're gonna still create a container, and how to create a container, how to go inside and check out the container. It's not a very in-depth lab with the containers. If you're a programmer, developer, I'm not a programmer or developer, so there is a limit to it. You can create it, you can try to check if it is created. Other than that, why would you want to use Kubernetes? And well, what is Docker? So container, Docker, Kubernetes. These are the main topics that we want to know what they are, right? So for that, what's the difference between virtual machines versus containers, and why use container instances? So first of all, there's a reason here, and ignore that there's Azure written here. This is Azure slash AWS slash GCP slash whatever other cloud, or Oracle, or whatever other cloud has. They all use the container for the exact same reason, right? So here Azure, GCP, AWS, container instances are useful for scenarios that can operate in isolated containers. So container instances is useful for scenarios that can operate in for scenarios. So what are the scenarios? We're going to talk about that in isolated containers, including simple applications, task automation, and build jobs. So the main the main emphasis is on simple applications and task automation and build jobs. So when it comes to simple applications, so you can, there is SQL Server container as well. There are other applications, but it's normally for simple applications which can be deployed in very large scale, which do not have to be started slowly, and which can be portable really fast. So simple applications can be used for containers. Task automations or DevOps really do that. Development and operations team, where you develop an application, then you create a workflow. What is workflow? Workflow is that the application gets created, now it is being deployed, and then it is updated. Then developers are still they're still developing the application. So they are still updating continuously that application that they have deployed already. So it's development, test, then deploy, and then update, patch. So that's a full workflow of for developers. So that's why they go for some lighter compute instances that really serve their purpose of portability and scalability. So, and build jobs. So build would be, first they would go for application creation itself, and then patch it continuously and keep on developing as well, and keep on updating the application as well. So containers, normally, what are containers? We're going to go for that. But what is the benefit of that? It's fast startup, launch containers in seconds, per second billing. So if you're using not more than 1 minute, so the next second's billing will not be charged automatically, or within an hour you have used for, so it's just per second, so you save a lot of money as well. Hypervisor level security, so you can even deploy containers on top of hypervisors if the Docker software is available. Custom sizes specify exact values for CPU cores and memory. Well, yeah, you can customize virtual machines as well, so that's not a big difference. Persistent storage, you can give persistent disk. Persistent just means that if you restart a machine, the storage is still there. If you the storage is there, it's not like when you restart, the storage is gone, or the link for the hard disk is gone. So it's persistent, it's just there whenever you shut down or restart a container. Linux and Windows containers can be created as well. So if we go down to this diagram, so you can see then that container, so virtualization has done what? Virtualization has abstracted the hardware, while containers have abstracted the operating system as well. So what happens is that the virtual machine, you create a virtual machine, you install a full operating system, right? So it could be a full GUI, it could be just core, it could be just CLI operating system, but you have to install the full operating system and one application in one virtual machine, right? We're talking about enterprise grade applications. So an underlying hardware is virtualized or abstracted. That machine thinks that it only owns that CPU and processor. This machine also thinks it only owns that CPU and processor there. and hard disk, and this also thinks while actually it is being shared between the three machines. So here you can have infrastructure. Infrastructure just simply means your CPU, your RAM, your hard disk, your network, right? So HDD and network. So on top of that, you just got one operating system, and on top of that, there's a runtime. What is a runtime? This is a software that whose only job is to run containers, whose only job is to host containers. Okay, so one operating system and maybe a lot of CPU, 32 core or 64 core CPUs, and 1 terabyte RAM, and terabytes and terabytes of SSD disk. You have a huge hardware there, and then you deploy one operating system on top of that, and then it's all Docker. One software you need that is responsible for hosting a container, right? So this software is needed to host a container, and application. Now what is this? These are all containers. So one container can have some percentage, some files of operating systems can be added here. So it's a really cut down to few files operating system. And the second thing is that it's offering an isolated environment for application. Isolated environment for application. So what is isolated? So if you install that same application, suppose I may have given that example before as well. Suppose the boss says, hey, can you install AutoCAD here, which is a big application. Then the boss says, okay, we don't have any space in any other machine, so can you install also Photoshop here, right? So that is also a big application, right? When you start installing Photoshop, so it says that please delete some files before I could go ahead and get you installed. And when you investigate, these are the files of AutoCAD. So now you can't delete the AutoCAD software, uninstall the AutoCAD software, and you cannot install also Photoshop on this. So they have their own dependencies. AutoCAD has its own dependencies and DLLs and files that it totally depends on for its own working. Photoshop has its own dependencies. So those dependencies, the whole application requirement, the environment, the dependencies is provided in a very light compute instance, which is called container. So in this container, first of all, there's full OS is not installed, and some abstraction of operating system or some files of operating systems are used here, and the application is installed here with that application has to be converted into a containerized application. So application has to be also made containerized, so made compatible with the container. So containerized app is an app that can be installed, deployed inside a container, obviously. But otherwise you can connect to a virtual machine. The full operating system is there, so you can just deploy any application. We know that already. We have been doing that so much. But if you want an application to be inside the container, suppose you want SQL Server inside the container, so in that case you need to learn how to convert an application or how to make an application a containerized application. There are many scenarios, there are many developers who have shown different types of codes there to convert, to create an application as a version which is supposed to be running inside containers. So there are a lot of codes out there. There are a lot of developers who have shown that in the YouTube video. Okay, Jitin says some OS files in containers means program files. Yes. What the the application needs some of the operating system file. Application needs to know that, oh, I'm installed on top of an operating system. Whatever operating system was supposed to provide, I need that. So yes, some files of the operating system which are necessary for the application to run are provided here. But if we provide the whole operating system in the container, then then there is no difference between virtual machine and container. Virtual machine starts slow because of the full OS installed there. Container starts fast because full OS is not installed there. It's just abstraction of the operating system. Some DLLs of the operating systems are there, exactly.
So application-wise, which one is faster?
So container is much faster. That's one of the big benefits that
Okay.
containers is, used by the companies. Container is really fast because of that, and container is portable. So first thing, it's fast because it does not install the full operating system. Second thing, it is portable. Now, what does that mean? You have container deployed on top of Docker, right? Docker is that software. It is also called runtime by developers. So you have that. There is another runtime called Container D. That is also that is also a runtime. So Container D. The more you go in depth and start reading, it gets crazier and crazier and goes more towards developers. But anyway, there's another runtime here. What is a runtime? It is a software that hosts containers, right? And there's a Docker which is much more famous. You will just see majority of the time this Docker installed, and Container D also does that, but it's not that famous. So suppose you have the virtual machine on GCP, container on a GCP, right? So GCP, AWS, and Azure, and all other cloud providers, what do? They say that, hey, you just start the wizard of creating a container. Underlying, we are providing Docker software for you. We already have a Docker software. You just click, and you create a container and just choose CPU, RAM, disk, whatever you want. But you don't have to really install Docker yourself. We are providing that to you, right? Milad says in the chat, so each of the cloud providers have their own, yeah, there you go. So they all have the Docker service already made available. You just start the wizard of the container and click. Or if you have a Linux machine, or if you have a Windows operating system, all you need to do is go to the docker.com and deploy the free Docker software on the Windows, and then start deploying containers on top of Docker, or on Linux, start deploying containers on top of Linux. So this is easier to just start the wizard of containers and then deploy it. But how about if we deploy the VM ourselves, the CentOS VM, and then on top of that we will deploy Docker ourselves as well. This is going to give us more learning benefit, and then on top of that we're going to deploy container. Okay, right? So this way we will learn that, oh, okay, this is how to deploy Docker, and this is how to deploy VM. Otherwise, cloud services providers, CSPs, already have that facility available. But if we can deploy ourselves, then this will be better. Manually doing it is better to understand this whole thing. What to understand here is, once you deploy Docker, then you are able to deploy containers. If you don't have Docker, forget that you can have containers, right? So one virtual machine you can deploy, and on top of that you can deploy a Docker. After that, it depends on how much CPU, RAM, and processor you give. You can keep on deploying containers after containers after containers. Just like virtual machine, the more CPU and RAM you give to the underlying hardware, the more virtual machine. But virtual machines are heavier, they are slower, right? Because of the full operating system there, and the containers are lighter and faster. So, and lighter and faster is one benefit. Being portable is the second benefit, biggest benefit. And portability means that if you install on top of Linux Docker software, if you install on top of Windows the Docker software, or you want to move the files of the Docker, files of the container from Linux to GCP or AWS or Azure, or from Windows, you want to move the files of the container to GCP, AWS, Azure. So yes, it's portable because they also have Docker installed there. So all you're doing is putting the container files on from one platform to another platform which also has a Docker software. As long as anyone has a Docker software, you can just keep on moving those container files to that, and it's gonna run. So that's why is it so big deal. So what if we can do that? Well, the thing is, try to do that with virtual machine. What do you mean by that? If this is a VMware virtual machine and you want to upload it to Azure, so you have to convert the VMDK, right, to VHDS, right, and then you can go ahead and upload that. And that's sometimes it's not a very nice experience, because some of the files might get affected because of the conversion of the format as well. And if you want to upload the VMDK to AWS, it converts as well. If you want to upload VMDK to GCP, it converts as well. So virtual machine portability is not that user friendly and risky. It's also risky, but the moving container, it's just a container which requires a Docker, and everyone has a Docker software, so you can move the container file anywhere without doing any conversion. So that's another very big benefit. So programmers have been using that for a decade now, more than a decade, with Google Cloud, right? They've been using that, but now it's the companies are seeing the benefit after the cloud has been introduced in a lot of companies. I'm just coming from a project, and it's they are also totally on cloud. Totally, I mean, like totally on cloud. So, my MS Office and Azure. That's it. So the whole company is on cloud. So they are just otherwise normally I or majority of the time I see that there's hybrid environment. So on premises plus cloud, but few company, but they don't have a lot of users, so it's not a very big company as well. Okay, so here we have talked about that. Okay, containers are fast, light, and very portable, and portable friendly, we can say, right? And that's why you can have in lesser space or lesser RAM more containers, each container having a one independent app. Or suppose you deployed web here and web here as well and web here as well, and it's exactly the same application, and you then did load balancing, right? LB, right? So well, the benefit is still there, that it's cheaper than virtual machine, it's lighter and faster than a virtual machine, and it's more portable than a virtual machine. So all those benefits plus more compatible with all the programming languages, and programmers can test easier on a container than on a virtual machine. Now I again am saying that I wish I was a programmer. I would be excited to go really in depth, but at certain point, the terminology starts, such kind of unique terminology starts, that we're like scratching our head. Hey, we wish we were programmers. So whatever I can stretch, I'll try to go till that. So okay, we get first of all the virtual machine difference and the container difference here, and let me just print screen that, and put it in the diagram. Okay. Oh. Uh. Well. Okay. At the end. The end. Well, I don't know why I did right today. What's that? Okay. So let's go ahead and try to. Yeah. Go for virtual machines versus containers: less development overhead, less resources consumed, smaller size, faster startup, reduced and simplified updates. Okay, it's smaller, lighter, faster, portable, blur. So we get that, all those benefits there, right? And then it comes to Azure Container Services. Now, obviously, you may have seen that slide before as well, because container is the same on AWS, Azure, GCP, Oracle, everywhere. Container concept is same, right? You just have to click, click, click. So I'm just gonna try to go ahead and check out. So what's our plan here? The plan is that we're going to deploy a VM here, and that virtual machine is send OS, and on top of that we're going to deploy our Docker, and on top of that we're going to deploy a container. But we haven't talked about. Okay, we know what is Docker. It hosts containers. We know what's a container. It's lighter, faster, portabler than virtual machine. Then what is that Kubernetes for? So that's easy. If you have a few containers, you don't need Kubernetes. If you have few thousand containers and you need an orchestration software to manage thousands of containers, then you need Kubernetes. If you have few containers, you do not need Kubernetes. So it's like suppose you have SCCM, System Center Configuration Manager. It lets you manage thousands of machines, right? So Microsoft Intune, it lets you manage thousands of devices, tablets, and cell phones and stuff, right? So that is so Kubernetes is like that. You have thousands of containers. Go for Kubernetes. You don't have it, you don't need it, right? Because they're gonna definitely charge you, obviously. But if you're a big company, then it's okay. Doesn't matter. So Chandan says means Kubernetes used to manage containers, nothing else. Yes, Kubernetes is only there to manage thousands of containers. That's all. So nothing else. But and it's so they've made it so kind of tricky that it's I would get it. My problem is always how do I make it easy for students to understand. That's where the whole problem starts. So I'm sure you guys are technical, I know that, but it's not that straightforward to explain that. But some guys on the internet, I salute one guy here, and give the credit where it's due. I always believe in that, and I don't try to hide anything. That am I getting the help from? Yes, of course I need help. I am not. It's not like I created that Kubernetes myself. I needed help from some people, so I kept on searching for videos where they anyone can explain in a very very amazingly simple manner. So there's this guy who I salute for making it so simple. Actually, you have to listen to that video like 3 or 4 times. Then you will say, okay, now it's simple. Before that, it's complicated. But then the way he explains, I'm just gonna share that video with you, and you want to go in to the basics of Kubernetes, which is no not at all basic. It's even the basics are complicated. So, but this guy is wow, like amazing. I salute this guy for making this topic understandable in such a manner that I was just blown away. So let me just get that up and running. Which one? No, not all of his are blown away topics, but one where he talks about Kubernetes with analogy. That is like you have to salute this guy. You have to really. Oh yeah, this one exactly. That was 10 minutes. Okay, so I'll just put that. The best way ever to explain Kubernetes. There are many other who have explained Kubernetes, but this is the best way to explain. Best way this guy explained Kubernetes components. It's not just what is Kubernetes. It's the components. The way he explained it, nobody else, I think, explained it better. So there we go. And I'll put it in. Kubernetes. Okay, so well, that's Kubernetes, but basically what I'm telling is that you have few thousand containers, go for Kubernetes. You have few containers, don't go for Kubernetes, right? Okay, so but let's just go for CentOS, Docker, container, and then go ahead with the next stuff as well. So I'll just connect to the the okay. I will connect to the GCP. Okay, there I had already created a Kubernetes, and that was quite some experience. I had to take out time, and offering 4-in-1. This is like I love teaching, but I found it this time it's too much for me. I was again offering 4-in-1, but now I'm thinking of just going for 1-in-1, whatever that means. Okay, so okay, let me just go ahead and shut down this dude. Hopefully it lets me. So let's just quickly create a project and quickly create a VPC and quickly create one virtual machine with CentOS. Okay, has been shut down, thank God. So I'll just go ahead and create a new project here, and then new project. So that's today. 04Jan2021. Wow, feels nice. Okay, so create here. So first thing is the project. Once we create the project, then we go for the next one. Well, so I'm just gonna put that here, not here. There are other videos as well, but you follow this guy, and this guy is a developer actually, a programmer and a developer. But the way he explained containers, especially Kubernetes, that was like blown away. But yes, fourth or fifth time was blown away. First and second time, what? Okay, so yeah, create project. I had created a project right away, so I'm gonna create a VPC. Then I'm gonna create a firewall rule. You know the drill now, and we go for CentOS VM, and the other exciting thing was that CentOS I really wanted to um, explore more, and so thanks for making me do it. Otherwise, I'm a very lazy guy. But when the pressure is up, then it's really fun to do. Uh, but yeah, Linux is something I have been avoiding intentionally, and I should not have. Okay, here, so once the project is created, I'm just going to go down to this VPC, and in the VPC, I'll just quickly create a VPC right away. VPC 1. Oh, okay, we have to enable computing. Really? Oh, we have to. Alright, so that's one thing, and while it is getting created, so this is the plan. I create project, create a VPC, create a firewall rule, create a CentOS VM, connect to it, install Docker engine. So firewall rule would have port 22 ICMP. Actually, it's not two machines we need, so we don't need ICMP. But other than that, create a firewall rule. So other than that, yeah, although we also don't need port 80 here, but anyway, actually we do. So we're gonna add these three. So let's see. Okay, so once we have the VPC up and running, not, okay, I'll refresh. Oh, you're kidding me. Did I create? Oh no, I did not create one. Serious. I'll click the create VPC now. Create VPC network. I just enabled the API for Compute Engine. So VPC CPC VPC1 and custom. So I'll go for subnet 1-VPC1. Although just subnet is also okay because we're just gonna create one. And US East 1 and 10.0.1.0/24 and private Google access, flow logs, regional, everything else is okay, just the subnet name, region name, and IP 1.0, and I'll click create. So then there are those screenshots there. So okay, once VPC is created, then we still need to create firewall rule. Then we need to go for create a send OS. So there's VPC1. I'm just gonna click that VPC1 here. And once we go down to the VPC1, then there is VPC network peering. Oh, sorry, why am I going there? Firewall rules, and then add firewall rule. We have done that before as well. So add firewall rule, and that is 22 ICMP 80. You can name it any way you want. So if we go down here, VPC 1000 priority ingress allow specified target tags. It's all instances. So I've given just the name up there. Oh, lowercase letters, numbers. Okay, port, and no commas, I think. Okay, port -22-ICMP-80. All instances in the network, IP ranges, and 10.0. Oh, what am I doing? So source IP range would be 0.0.0.0/0, and protocol 22,80, and ICMP here. So here it's 2280 and ICMP. So that's it, and all instances in the network, and this, and I'll click create now. And once we are there, port rules have been done. So now we're gonna go for create a CentOS, connect to it, install Docker engine. So update packages first of all, and then config managers, lots of commands here. Okay, here's version of okay, so here, yeah, it's done. Okay, so I'm gonna go to the navigation menu here, and I'll go to compute engine. and I'll click create VM instances. And we're gonna go for -VM1 or -VM. That's the only VM we have. And we'll go for South Carolina US East 1. So all the same drill here. And we're gonna go for Debian Linux. Oh yeah, we're not gonna go for that. We're gonna go for CentOS. And CentOS 8. The same thing, right? CentOS and CentOS 8. Allow default access, yes. I'll also click allow HTTP, right, for the virtual machine. And I'll connect it to this virtual machine to that network card. So I'm going to click networking and click the network card here. CentOS 8, allow default access, HTTP traffic, and there's a network card. So we did that before multiple times. So I'm going to go for the network card, and I'm going to tell it I've created a VPC 1, and I have a subnet 1 there, and that's it. Done. So its networking is connected, so the virtual machine is connected, CentOS virtual machine is connected now to the VPC 1 subnet 1, and it has CentOS 8, and it has HTTP port traffic allowed. I'm going to click create. Okay, so I'm going to connect to that virtual machine. I hope no surprises are there. SSH and the first line. Okay. So first we need to connect to it. So, okay, so that we always do. Change the root password and switch to it. I'll just add that step as well. And change the root password and switch to it. So I'll go for sudo passwd, and then it's asking for changing the root password. Sudo passwd, and then small abc, capital ABC, shift 123 without shift 123. Small abc, capital ABC, shift 123 without shift 123. And then I'm gonna switch to root. So I'm gonna just type su, and small abc, capital ABC, shift 123 without shift 123. And okay, so yeah, we have done this as well. Now we can go for actually there is update this CentOS. First you have to have all the updates, and then you can go for Docker, right? So that would be another command. So if I go down, yes, this is the switching we did. And then show information about available update packages, run sudo yum check update. Instead of check update, install the yum utils package, which provides the yum config manager utility, and set up the stable repository. So this is sudo we use at that time if we are not logged into root. So since we are logged into root, we don't need to use this command. So I'll just remove that and yum install -v yum utils. So that is config manager there. But first of all, we can just go for this one as well, which is actually this command without the quotes, yum check update. So not sudo yum, but yum check update. So I'll just go for that. I'll put it here, and also yum check update, right? Yum. So yum check update. Dash update. Okay. So it's actually some MB, some KB is being downloaded as well, installed as well, and done. So that's the first one, and then second thing is you need to have config manager installed there as well. So yum install -y yum utils. So that's the command. So yum install -y yum dash utils. So I'll just copy paste that. Install -y and yum utils. So it tries to then check all the if this machine is updated, and the config manager that will help us install the actual Docker. So for that, the config manager has to be there. Now once that is done, yum install. Okay, we did that. Now there is that yum config manager add repository, yum config manager -add repo, and there's a website here. From the repository, try to get the Docker version that is the latest one, right? So this is Docker CE. So I'll just go for get the Docker in CentOS from the docker.com, right? So there is that command that we can type there. In fact, this backslash is for using separate lines, so I'm just gonna remove those backslashes and make it a one line command. This URL does not come up, so I'll just go for, in fact I need to remove the sudo from here. Okay, now this is the full the command starts from here, so it's without quotes. So I put the commands there as well, and I'll copy it. Oops. Till here within the quotes. Adding repository to this. So it's the config manager that is supposed to get that Docker path there in the repository. So we told it, hey, there it is right now. And then the next one is install Docker engine. So install the latest version of Docker engine and container D, or go to the next step to install a specific version. So there is that. Obviously we're going to go for latest version here for Docker engine, and we're gonna again go for this command here. Since we are in root, so we don't need sudo, and we don't need that dollar. Oh, we need dollars. Okay, so now we get install it as well. So I'll go back to this. Okay, so it goes for all this information and shows your Docker CE. Then it says that, hey, the installation will be 433 megabyte, total download size will be 106 megabytes. So is this okay? I'm going to type Y, which is yes, and enter. It may ask again. Yes, no. Yes, it is asking. So importing this user ID fingerprint from this, so it is okay. GPG, this is security information. So I'm going to type Y here as well and enter. Running transaction. So we're just trying to install Docker, and on top of the Docker we need to deploy a container. Okay, so the Docker has been installed on top of CentOS 8, which means that it's ready to grab the containers. It's just that we have given such less CPU and RAM to this. So the only difference in a production environment and here would be that you would give huge amount of CPU and RAM if you want a lot of containers to be deployed on this one virtual machine, on top of this one virtual machine, on top of the Docker software, right? So here, all right, so if you go ahead, until now it's the Docker has been installed, and we have pressed yes and yes and yes. Now done installing Docker, right? So Docker is installed but not started. Is it started? It is installed, but is it started? So for that, there is the command start Docker. Well, it's not the command, it's the actual explanation. The actual command is, I'll just remove sudo from everywhere because we already logged into root. So it is systemctl start Docker. So this is the command for that. So systemctl start docker, and other than that, verify that Docker engine is installed correctly by running the hello world image. So there is a command for that too. And first I'll just try to start the Docker, and I'll go for first it's systemctl start docker, and then docker run hello world. If the Docker is installed, docker run hello world. So it's just inside the Docker, one basic image is installed just to check that can we communicate with it, can it be deployed. Hello from Docker is showing there. This message shows that your installation appears to be working correctly. To generate this message, Docker took the following steps. The Docker client contacted the Docker daemon, which is a service or daemon. The Docker daemon pulled the hello world image from the Docker hub. The Docker daemon created a new container from that image, which runs the executable that produces the output you are currently reading. The Docker daemon streamed that output to the Docker client, which sent it to your terminal. So now to try something more ambitious, you can run Ubuntu Container with docker run -it ubuntu bash. So now the Docker is there, it ran an inbuilt container, and it showed you this message hello world, which basically says that yes, Docker itself is ready, and you want to deploy some other container, you can go ahead and do that. So that and it says here hub.docker.com has huge amount of containers there. You can just deploy any one of those. So if we go ahead now, docker run hello world. Now we can also do another check, ftir. Okay, it's just ftir written here. I'll just add a. After Docker package has been installed, start the daemon, check its status, and enable it system-wide using the below command. So systemctl start docker is there, systemctl status docker, systemctl enable docker. Now later, suppose the machine restarts and the Docker is not started again. So for that, so system ctl. Okay, let me just copy those. I'm putting the website name as well. So these are just three commands there that you can go for in order to really. So systemctl status docker. It's a status. It stays here until you control C out of that, and then systemctl enable docker if it says credit symlink. So this just makes it possible for the Docker to the service to always stay automatic and it started, right? Okay, so for system-wide Docker, system-wide information on Docker, there's Docker info. So well, that's just you want to play with Docker commands. There's a lot of Docker commands there. Docker info just gives you info about the status of. So this is enable Docker. This is Docker info that I wrote there. So context, debug mode false, Docker version is this, build with build kit. It goes on. There's one container. It's a built-in container that it created, and that is to just run that hello world just to check that if Docker is working fine or not. So it can take more containers there. So well, you can just read, and there's a lot of information there. And then for Docker version, that's another thing here. So if we go for so I'll go for Docker version as well, and this is version 20.10.1, and the rest of the information. To get list of all available Docker commands, type Docker on your console. So just type Docker and you will get all the commands there as well. So these are all the commands. Management commands are there, and just commands are there, and self-sufficient runtime for containers. So all Docker related stuff is here. So what the SOC says, how much is the capacity of one container to store information? So well, it depends on the capacity which we provided from the underlying machine. So if that machine has more RAM, so this is the infrastructure. When we talk about infrastructure, this is the virtual machine. It has one operating system, and then on top of that it has a Docker here. So now if the more CPU RAM you give, the more containers you can have. The less CPU RAM you give, the less container you can have. So it depends on the hardware. This goes the same for virtual machines as well. You can have 30 virtual machines here if you have a lot of CPU and RAM. Or you have just 2 virtual machines if you have less CPU and RAM here. So it depends on the hardware. And there it is. Okay, so here, if we go for, yeah, I changed it, sudo password and everything. So now what we can do is switch to root. Yeah, we did. And not only switch to root, there was one machine that I tried to, in fact, yeah, I downloaded it, and that one container I downloaded, and Docker pull Ubuntu. So we went for pulling a container. So how is this working? We have till now CentOS 8, and we have a Docker, and we are about to install a container. So we already have CentOS here. So when we deploy a container here, so it needs to have some files of some operating system, right? Some binary tables of operating system. So what happens is that this container, we can deploy actually Ubuntu files here. There are so many containers here, but yeah, once you deploy one container, this is the way to deploy 1,000 containers as well. Now container, I'm gonna go for one more container here that is showing here. There's a long command showing here, and this was actually a very interesting one. There was a website inside there. So container deployment command, I'm just typing here, although somehow it did not run for me at that time, although well, it was running for others but not for me. 90, 80. So I'm just typing this. I'm going to copy paste that there as well, and then I'll just deploy this container. It's available there, but it is an old one. Normally what it is a website that has a game. So a container, inside this container is a web server. Web server has a website inside, which is a small website, and it's a very small game on that web page. So that's the path of this. It gets installed, but for others it was working. Others means that the guy who showed that it was working for that guy, Super Mario. So this was a path for that. Maybe its latest version might work, but even that I tried, it didn't work. So this is what this is. We can deploy this container which has a web server, a web page which shows a small game, right? So this is that container. We can deploy this container on top of the Docker we just deployed. So I'll just quickly put that there. If anybody is following, you can try that. And first, because I have a Docker, I can deploy multiple containers. We can delete containers, we can deploy containers, right? So I'll just go for this one line docker run. Docker run is the command to run anything that you want to run in Docker. So it starts with docker run. So I just pasted this command, and it actually downloads the whole container, and then that container is supposed to be started, and that container is supposed to be started with the web server automatically inside, and then that container is supposed to just show all show that website, that link, right? So what happens is that if I go here, so the next command is, so first of all I deployed the container, and containers are small, they're light, so it didn't take much time. And what is the space? It took very less space. Actually it was showing some megabytes for each file of this container. But is there any container that got deployed? Are there any containers that got deployed? So there's a command docker ps, and that actually shows the whole, so it's a process information. The docker ps shows how many containers are there, right? So there's that command as well. Okay, so there's docker ps here. I'll just go for, well, I'll just type it, docker ps. So it says that there is one docker by this name, paying by, and it has catalina.sh run is the command. About a minute ago it was deployed, and port 8080 it would go for, and it's there is 10 here, and 000 colon 1990 and 80 TCP, and so it's just the ports that are there, and but it's saying port 8080, so that kind of will mess up as well. So this is deployed on what? This is deployed on one virtual machine that we have here, right? That's the first content. This is not Ubuntu container. This is just a web page with a game, but I think I messed up with the ports here. We're gonna then deploy the Ubuntu container as well, which is a second container, and when you ps that docker ps, then you will see that it's the second container. It will be second container. We will be deploying that. We haven't deployed that yet. So if I go back here, so when we go for docker ps, so there is that container id, right? And container id is this AE586 something, and that's the docker, it's the name of the container. It just puts that name. Now if it was a web server, as it was claimed by the creator of this container, then I should go to that Google Chrome. I'm there. This is the instance inside which this is sent to us virtual machine, inside which we have Docker, inside which, on top of which we have a container. So if I go for that public IP, so normally it's supposed to just open up that, if it was a correct web server, and if I had not messed up with the ports there, then it would show simply a website. But this is just something that I deployed. We can just deploy any container here. I did work with the ports as well. I opened that port 8080 in the rule as well. In fact, let me just do that once more. I'll be quick on that, then we will go for the next container. So in the VPC and inside the VPC, because I gave that port 8080 there, that open that website on that port 8080. So I'll just quickly add here in firewall rules. You can add many ports there, right? So I'll just add one more port here, that is I'll add it in the firewall rule and go for comma 8080, and the machine port is actually 9090, but this is just 8080. We're just saying that on this port also accept traffic, and well, this is something that is just a remote experiment, but you can deploy any type of containers there. That's the main point here. But when we deploy the second container, this was just an experiment, and when we deploy otherwise we have deployed Nginx container, which is just a web server as well. We're going to deploy now another one. So Docker search to see how many Ubuntu images are there. Now the next command is Docker search. Now it can search. There's a command here, Docker search, right? And this command, so suppose we go for Ubuntu. So this is actually a command. Docker search, after that you type Windows, it's gonna search for Windows. Docker search, after that you type SQL, it's gonna search for whatever number of containers about SQL, whatever number of containers about Windows are there. So there's this command there, Docker search to see how many Ubuntu images are there. So if I put that, so once Docker is there, there's so many Docker commands there, right? So this is the area, and it's okay. I'll try to put another background here. Okay, now the background is, otherwise it was confusing, right? So I'll go for Docker search, and suppose are there any containers that have Windows? So I put Docker search Windows. So there are containers that have Windows, or Docker search IAS. How about that? Docker search IAS, Internet Information Services. So there is Microsoft IAS here. We can deploy just this Docker pull Microsoft. These are the name of the containers, right? That are there, and if you put Docker pull plus the name of the container, it will just simply pull that container from docker.com and will deploy it here. And then if it's a web server, then the public IP of the machine should open that first site as well. We can even try this. I'll just go back to the command. So Docker search is a command. It gives you Docker search and whatever word. So do you have a container for Docker search Oracle? It will search all the Oracle containers there on docker.com. Then the next command is Docker pull and whatever image name you found, right? So Docker pull Ubuntu, or I just found that there was a IAS. So Docker pull IAS. So first I'll go for IAS, then I'll go for Ubuntu as well. So if I put that here, Microsoft /IAS. If I go for Docker pull, this means pull the image from docker.com. What is the name of the image? Suppose I go for Microsoft /IAS. Using default tag latest pulling from this, no matching manifest for Linux in the manifest list. Okay, yeah, so I think it's not going to go for Microsoft on a Linux machine, and it should not actually. So I'm going to change that back to Docker search, what I was doing actually, Ubuntu. How many images are there? So many images for Ubuntu here, right? Okay, where's this command that I just, yeah, this is the command I just gave, and it says that there is a image name which is just Ubuntu. That's it, right? So how about I go for Docker pull Ubuntu. and it start downloading the very small container of Ubuntu into the Docker from docker.com. Okay, well, there is Docker PS to know that are there any containers. So Docker PS. Okay, no, it just shows one. So container ID is just this. That's not good. There's supposed to be 2 containers now. I just put that Docker PS again, and container ID only this is coming. So this means that okay, Docker images would be the one that would tell us that are there any. So Docker PS would just give you that if the container is running, right? Docker images tells you how many containers you have. So if I go to Docker images, so it tells me Ubuntu Hello World. Yes, that was the default container inside the Docker software itself, and being by / Docker Super Mario, which never ran. So but Ubuntu is also there. If we keep on downloading more, suppose Docker search Nginx. So Nginx is a web server, right? So are there any? So this is Docker images. This is the command I gave, Docker run. So there's Nginx name here as well. There's a container on docker.com that is called Nginx. So if I go for Docker pull Nginx, it goes, it's very light, download speed should be okay as well, good as well, so it downloaded that too. Did it? So Docker images will tell you if there are more containers now. Okay, there are actually. Nginx is there, Ubuntu is there now, Hello World was already there, ping by didn't work, right? So there are 4 containers there, and you can see that they're very small in size. Obviously you would go for bigger containers, so they will be bigger in size. So there are very large amount of containers on docker.com. hub.docker.com, you will see huge amount of containers there. I just went for those that can be tolerated by us. Yeah, Docker is running, and if we go for now, in order to go inside the container, after that you have to be Ubuntu expert. So to launch a container, then it is docker run -it ubuntu bash. So that's for Ubuntu. So if I put that there, so okay, now what happened? As soon as I run that command, I'll just change the background so we could clearly see that. So I said that, hey, can you run Ubuntu and bash shell so I could run command. So it changed. See this, the root at instance 1 VM admin was there before. Now it says root and some weird ID here, right? What is this weird ID? So we're inside the container now. Really? Sudo if we go for host name, hostname. So it gives you a very weird name here, right? So if I go outside of this container, Control C does not do that actually. Exit. If I just type exit, I am outside of this container. Now the prompt changed from root at instance.vm. If I go for host name here, so it gives me instance 1 VM. Now I'm going to go back to up arrow, and I'm going inside the container again. And now I'm back. And again, if I go for host name now, it's this weird name and ls. So it's a list of all the folder structure of the container which is having Ubuntu files there, right? If I again exit out of the container, so if I go ls here, well, we're not in the root, or folder structure is not here. And if we go for if config, so if config shows us that this is the IP of the virtual machine 10.0.1.2. I'm going to go inside the container, which is on top of a Docker, which is on top of a virtual machine that has sent to us, right? So if config here is, we already did that. I'm going to go inside the container now, docker run -it ubuntu bash, and then sudo if config. I think it will run that. Ubuntu, how does it run? If config. You know why they don't just all follow the same thing? So here, seriously, such a simple thing. So how to see IP in Ubuntu? Really, you have to show a whole video for that. How do I find my IP address in Ubuntu? Really? Are you? Ubuntu. Command to C. Okay, I'll just go for command to C. Now, can you spell it out? Oh, okay. Here it says. Oh, really? Okay. Let me just watch the video. Go. You know, they just want to be famous with the commands. Oh, what command did you give? It's if config. Seriously? Okay. He made me watch the video. That's not fair. So yeah, if config is actually in the container, it's Ubuntu files, but if config is not really ls, I think we have to go inside some folder structure like the one that has /etc or boot, and then root, cd root, and then if config, or because I'm already in the root, right? So if I go su, yeah, I'm already in root. So anyway, we're inside the container. It looks like this, and if you're a Linux expert, then you can install. Oh, okay, there's one more thing. Exit. If I go to, you know, we have another container called Nginx, and that. Oh, I'm inside the container now. Exit. So there was Nginx there as well. So does the same command work for Nginx as well? Yes, we're inside Nginx now, and it is running ls if I go for, so it has some folder structure here. So I'm just going to go back to the machine here, and I'll check that if Nginx is open. Can we see a web server here? I actually started multiple containers, so it's if I had just Nginx only, then oh, what am I doing? I need to go for the public IP, but there are multiple containers here, so one public IP is mapped to what, so that would be then an issue here as well. So that is something That's why if I had just deployed the container for Nginx, which is a web server, then it should have worked. But I deployed actually multiple containers just to show that what are the Docker commands and how many containers, how you can deploy containers, how you can search for containers, and once container Ubuntu is installed, then if you know Ubuntu, go ahead and start searching for whatever you want to do in Ubuntu, right? So, well, that's we installed a machine, and if it was a Windows 2019, we could install Docker on top of that too, and we could just play with Docker commands on top of Windows 2019 exactly the same way. Docker commands are same on Windows and on Linux. Docker commands are same everywhere. So that's a good thing, right? And if I go for Docker PS, I'm inside the oh, actually, you know what? Only one is running. Huh. Okay. Anyway, I'll just go ahead. Well, that's we're inside the Docker now. Oh, like we were inside the containers, and then you can just simply go ahead and try to check how they can work. But you can go inside the containers, and you can see how they're going on. So you can stop the. So there's a question how to switch between two containers in Docker. So you have to run the containers. Actually, I have those commands dug out somewhere. How to run and stop Docker container, right? So run and stop Docker container. Then there is run and stop Docker containers, Docker start. So normally you just put the container ID and then give that container command Docker start my container. So there's Docker space start and whatever the name of the container is. So if I just try that, first of all I go for Docker images, and then I go for Docker start Nginx. No such container, and Jinx is not okay. If I go for really, okay, yeah, that I'm on CentOS, right? So I have to check that. No, actually, Docker command is supposed to be working for everyone. Ubuntu. No response from daemon. No such container. Ubuntu. So let me check if Docker service is even running. systemctl status Docker. So it says active running. So yes, it is running. Control C. Okay, let's check some more. I think everywhere it's gonna tell you Docker start is to run your Docker container. Run utrack Docker container. No, that's just for that specific container. Docker stop, Docker start. Okay. And Docker stop container, that's the same thing that I just saw there. And oh, that's both sides are the same. So I'll go for Docker attach, Docker config, Docker cp, Docker create, Docker images, yeah, we know that. And Docker load. So it goes on Docker base.
Docker container. You can go up.
Oh, Docker container. There's this.
Go up. Manage the container.
This one.
Yeah.
Ah, cool. Docker container and command. Okay, Docker container start, I guess. So, okay. Docker container. Actually, first if I just give Docker container, then it goes for all these Docker container ls. ls just shows me one container list containers. Seriously? and restart one or more containers. Docker container restart. Docker container restart -1 help, Docker container restart, and the options and the container name. So actually I installed that, and it actually says it does not find any. So that's very strange, the way we installed other containers. So guys, let me just quickly go for one more search here. How to install and run Ubuntu container in CentOS. So add the Docker. So we were able to enter the container, right? But then how were we not able to just run it? If we can enter it, we can click we can see the host name of it, and 7.2 CentOS container on Ubuntu. Oh, CentOS container on Ubuntu. Seriously, in Ubuntu. Okay, so that goes. This search just is not very good. Well, the thing is, if we are inside the container, so this is one of the sites that is giving a lot of commands. Docker version, Docker only, download a Docker image. Yes, see this, Docker search Ubuntu, and then Docker pull Ubuntu, and then Docker images Ubuntu shows. But if you don't need a Docker image anymore, okay, Docker RMI Ubuntu, that is remove Ubuntu. Run a Docker container. So Docker RM is always remove, and then Docker run Ubuntu this. So in order to create and run a container, you need to run command into a downloaded image, in this case Ubuntu. So a basic command would be to display the distribution version file inside the container using cat command, as in the following. So first he does this, and then Docker run. The above command is divided as follows: Docker run, image name is Ubuntu, and a command to run into container, Ubuntu cat /etc /issue. To run one of the containers again with the command that was executed to create it, first you must get the container ID. Okay, Docker ps -l, get the container ID. Docker start. Oh, so there we go. Docker start and the container ID. I'll try to check that. Otherwise, let me just check this. Oh, Chintan has one. I'll put that website. That really is very good. I'll just copy paste the command that Chintan has put there. Restart one or more containers root. So this is the command I put, and it says error response from daemon, no such container engines, configuration complete, ready for startup. So is not empty, will attempt to perform configuration. Okay, well, there is that already showing here, so I'm just going to go for Docker images, and if I go for Docker images ls, so actually it does not show the repository tag image ID created size, so it's just downloaded image. It does not. Docker ps -l, let me just check that. Docker ps -l, it just shows, oh, it shows nginx, right? You know what, your command actually did start the nginx, Chintan. So yes, that's good. And then now it says, so if we go for Docker start, or actually it did give the ID there, so it did not start still. So Docker start, I'll just grab this. Okay, now it starts. So Now, yeah, it's running GC container. So, well, start is just showing that, and then once it is started, so we can actually go for docker ps -l, which is showing back there, this one, right? So nginx is now showing there, and we can stop them as well. So docker stop. So this website is really good with all the detailed commands. That's one thing. And second thing, I'll just try to go for that machine that if nginx related opens. Okay, it's kind of messed up machine right now with the different. I'll just do a restart here, or okay, stop. I'll stop the machine, start the machine again, and then try to run the container again once more. Otherwise, that site is there, and you saw the whole process of getting the Docker installed and then getting images installed. It's all about Docker run commands. How good are you in Docker run commands there? Okay, wow, it takes a lot of time to stop. If it was a container, it would have stopped faster. I'll start. Okay, it is started, and first I'll just put that public IP there if nginx or the web server is really in a mood. Otherwise, I'll go once more and connect. Okay, we're connected. And is Docker there? Yes, it has. And Docker images. Okay, no, get permission denied. Oh, okay, I'm not in root. So sudo docker images, does it work? Yeah. Okay, if I'm not in root, I can just keep on doing sudo, right? And then there was docker ps. Oh, okay, seriously, sudo docker ps. So right now it's not really running. I'll just go for that docker container run nginx that Chintan has put there. Oh, again sudo. Or should I? Okay, ready for startup. I'll do anything else after that. Or did I just stop it? Ready for startup. Okay, and the next one was docker ps again. Okay, it's still not showing, so I'll just go for one more for this. Docker container run nginx. Does it do anything after that? I'll just wait a little more. So it's a lot of playing, and until you get one image up and running. but we can still enter the container once it is downloaded as an image, and we can, so docker run and then docker stop as well. Okay, if it is running, normally when it says that it is okay, it's not doing anything else for long. Sudo docker, yes, but it's not showing anything as well. Now it's not really starting, so I'll go for sudo docker. Before it was showing, now it's not showing that. So guys, yeah, it's something that I have to practice as well. We have to practice. I try to get as much as I can, and docker pull images running. Is it running? Docker run it ubuntu bash. So yeah, we can just enter this and I'll go for again sudo it does say launching, and then it does say completed. So restart or run is giving me the same result, but I'm just maybe the IP changed. No. Okay, so well, this is something that I would ask you to keep on playing with. But what is a container, how to download it, install it, and then start playing with the Docker commands. It's all about your specialty or your expertise with Docker. But you want to go inside the container and check different folder structures of that. So we already have gone through that. So Ubuntu bash, when you go for that, so it does show you, it just takes you inside the container, when okay, got permission denied. So I'm inside the container, and host name obviously will be that, and then IP address, we have to ls, just gives the folder structure of the container itself, right? So if you know how to install any packages inside, you can do that. In fact, Ubuntu, well, it's all about Ubuntu commands after that, right? How many commands that you can give in Ubuntu. Actually, CentOS commands are different and Ubuntu commands are different. Yum does not work in Ubuntu, I think.
So when you start, like, the one command I give you, so don't press Control Z, because you have to keep it running and open another window, so you can see it is running.
Yeah.
Because when we press Control Z, it will tell you.
Yeah, it seems like that. It's you're right.
So yeah, press enter and then just open another.
Ubuntu is Debian, so it's different from CentOS. You read that?
Yeah, it is different. You're right. Okay, what am I doing? I just wanted to go back and Jinx.
But I think they both have the same bash shell.
No, some commands are different. Like yum or DNF. CentOS has different. Oh well, some commands are different, not all.
Hey, I don't think yum runs in there. Ubuntu. Yum and they have other package management system in Ubuntu. Yum is just package management, application to install, update.
Ah, good. Okay, and then obviously I have to get out of this tool.
Yeah, so no, minimize that and then open another one.
Okay.
Yeah.
Okay. And then go for PS, Docker PS, and check its
Yeah.
ID.
Docker PS, you can see there.
Good, thanks. Okay, let's go first. Yeah, you're right, man. And then, if it is running, well, this is restart, right? So, oh no, it's run. Okay, so when it is running, so it's engine, so it's a web server. So if it is working fine, then it should just show after some time or now, whatever image it has. We did that lab directly where container was installed. It was not on CentOS, it was on Azure container. So Nginx we deployed there, and it just worked right away when we opened the public IP there. So, well, after this, what you can do, just like now. So, this much I can go ahead with containers, and my suggestion would be just go more in depth with that and try to explore more. Because from here, it's kind of all command prompt and what do you want with the application inside and how much you know of Linux to play with, right? So until it is as far it is how it is downloaded and created and now run as well. So with also your help, we are able to check it out. But try to play some more. That's as far as I can go with containers. Now, other than that, um, we can. Oh, okay. One more thing. That command here, the next one that site was giving, right? There was that site Docker run, but that's Docker container start, and instead of the container ID, we just gave the name, so it's the same thing. And then Docker PS just shows that as well. Okay. So yeah, now what we can do is we can just talk about the Kubernetes as well, and in fact how to install Kubernetes as far as that as well, and why would you even want to go for Kubernetes? So Kubernetes would be that you are in search of a orchestration software. What is orchestration? Orchestration is you have huge amount of virtual machines or containers, so or maybe huge amount of devices. So you want to orchestrate any large scale inventory with a software. So that software is called orchestration software, which should offer high availability, scalability, disaster recovery. So then that software for containers, it is Kubernetes. It is also called K8. If you search for what is K8, it is Kubernetes Y8 because there are 8 letters here, and some lazy guy came up with this K8 instead of Kubernetes, saying it all the time. So hence it is also K8. And Kubernetes for beginners, Docker introduction in 15 minutes. So now this guy, I would recommend to go for his video is the simplest. There are other very good videos about Kubernetes, but first you go there, then you come here, then you go there, then you come here, then you go somewhere else and ask for Kubernetes, and then when you come here 6th time, now you will understand everything this guy is saying. So so that's how you know that this guy what he said is the simplest way to define Kubernetes. You know what, I should stop recording this when I'm starting this, but if I start explaining the way he's explaining, okay, I'll try that now, and then we will actually start deploying Kubernetes as well. So how do we do that? How do we do what? First of all, what is Kubernetes? So I'm just gonna go ahead and copy this. In fact, I've copied it already, and if I record it in the video and I've uploaded on YouTube, I think they will give me copyright error there. So that would not be a very good idea. So I'll just stop my video, and alright, should not then upload it on YouTube if I am to record it as well. So I'm just starting this, and I'll stop my video here. I'll resume that now. So guys, I have that video. I already did that. See this? I already did that thumbs up. So I gave the credit to where it goes. But here, what is he trying to even start to say? He's saying that there is one node here. This is one virtual machine. That is one node that is called master node, right? So that master node is handling everything happening with the container. So there's a master node that is just like the captain of the ship. It's trying to check that, hey, all containers are okay. So then there are worker nodes, and nodes, inside the nodes is a pod. This is a pod. Inside the pod is a container. So and you can give CPU and RAM to this pod, and that pod actually contains the container. If one pod goes down, another pod can be deployed as well within the worker node. So master node has these functionalities there just to control thousands and thousands of containers, and those containers are inside worker node. So there could be multiple pods here having multiple containers as well, right? Yeah, it can have multiple pods as well. Worker node can have multiple pods, and each pod having one container or even more containers. So this is, and then what kubelet does, what kube proxy does, what within the worker node host application as containers, and what does etcd cluster does, what kube API server does, kube controller manager does, kube scheduler does. So master node has to have certain components here to control thousands and thousands of containers and make them highly available, and also to make disaster recovery process also, and also scalable. So highly available, scalable, and to have disaster recovery processes there as well. So what does worker node really do? What is this component kubelet doing, kube proxy doing? And then the whole worker node, what is this doing? And then what is this container with one or two applications, one application inside is doing? So this is overall what it's saying. So first node is the master node. Two other nodes that he said in the start are worker nodes that actually have the containers that the master node needs to handle. But these containers, you will only come to Kubernetes if you have hundreds or thousands of containers, right? Otherwise, you don't need to come here if you have few containers. So I'm gonna I'm just explaining that where did he start even, right? And what was he saying? So that's why I just went to explain that he's talking about two nodes here. One is a master node, and
as many instances of your application.
When we go for that diagram here, so these are the two worker nodes that have the container 1, container 2, container 3, container 4, 5, 6, right? 12 containers here and 12 containers here. And these are the worker nodes that are carrying those containers. And if we go for this is the master node that has so many components inside that are taking care of the applications that are inside a container. When we say application inside a container, so that is app, and that is one container. Then that's a second container, app, right? There's an app here as well, and then there is another one, then there is another one, then there's another one, and here. So these are like 16 containers having 16 different apps, or maybe it's the same web server in 16 containers that's highly available, or one partner web app is here and its partner app is in another worker node here. So if this whole worker node goes down, its partner container is actually here on the other worker node, right? So this is kind of an analogy he's going for. This is the master node, these are the worker node. Worker nodes have the containers that have the application that the company really needs to work, while the master node is just making sure they work fine. You need more, it can arrange more. You need to make it highly available, it can do that too. So master node and worker nodes, right? So let's go ahead a little.
Cloud that host applications in the form of
Okay, so Chintan says it's similar to vCenter in VMware, where vCenter manage. Oh yeah, there you go. Exactly. So the orchestration software, exactly. vCenter can manage 35,000 virtual machines, and now vCenter 7 actually can handle. You can install Kubernetes and containers in vCenter 7. That's the new version. In fact, that course is starting with NetWest College this Saturday evening, where 7.0 we're gonna start, and that supports that totally new version, right? But yes, as you said, vCenter, it's like vCenter. This is full orchestration. vCenter handles huge amount of virtual machines. Now 7.0 version, virtual machines plus containers. vCenter handles that too. It's not vCenter, it's the Kubernetes that you can deploy with vCenter. And Kubernetes here handles thousands of containers. So exactly, that's a good example. Okay, so I'm going to just start that.
Containers. These relate to the cargo ships in this analogy. The worker nodes in the cluster are ships that can load containers. But somebody needs to load the containers on the ships, and not just load, plan how to load, identify the right ships, store information about the ships, monitor and track the location of containers on the ships, manage the whole loading process, etc. This is done by the control ships that host different offices and departments, monitoring equipment, communication equipment, cranes for moving containers between ships, etc. The control ships relate to the master node in the Kubernetes cluster. The master node is responsible for managing the Kubernetes cluster, storing information regarding the different nodes, planning which containers goes where, monitoring the nodes and containers on them, etc. The master node does all of these using a set of components together known as the control plane components.
So master node has control plane components here, and there will be components appearing here. Those components help master node maintain and manage these containers that have apps on top of them. So all the components are here in the master node.
We will look at each of these components now. Now, there are many containers being loaded and unloaded from the ships on a daily basis. And so you need to maintain information about the different ships, what container is on which ship, and what time it was loaded, etc. All of these are stored in a highly available key value store known as etcd. etcd is a database that stores information in a key value format. We will look more into what etcd cluster actually is, what data is stored in it, and how it stores the data in one of the upcoming lectures. When ships are...
So etcd knows that where are the containers in a key value pair, and it just knows the location or metadata of where the containers are and where have they been uploaded. So that's the first component of the master node of Kubernetes.
5. You load containers on them using cranes. The cranes identify the containers that need to be placed on ships. It identifies the right ship based on its size, its capacity, the number of containers already on the ship, and any other conditions such as the destination of the ship, the type of containers it is allowed to carry, etc. So those are schedulers in a Kubernetes cluster. A scheduler identifies the right node to place a container on based on the container's resource requirements, the worker node's capacity, or any other policies or constraints, such as taints and tolerations or node affinity rules that are on them. We will look at these in much more detail.
So Kube scheduler, it tries to know that which container should be on which worker node according to that container's app's requirement. So suppose there's a SQL Server app that is on the container, so kube scheduler will try to check that, okay, there's a worker node here that has 64 GB RAM and 32 core processor, so let me put that container on that worker node because it has a lot of capacity, because that container has a SQL Server that requires a lot of capacity. So kube scheduler will check that which worker node that container should be on.
Detail with examples and practice tests later in this course. We have a whole section on scheduling alone. There are different offices in the dock that are assigned to special tasks or departments. For example, the operations team takes care of ship handling, traffic control, etc. They deal with issues related to damages, the routes the different ships take, etc. The cargo team takes care of containers. When containers are damaged or destroyed, they make sure new containers are made available. We have the services office that takes care of the IT and communications between different ships. Similarly, in Kubernetes, we have controllers available that take care of different areas. The node controller takes care of nodes. They're responsible for onboarding new nodes to the cluster, handling situations where nodes become unavailable or gets destroyed, and the replication controller ensures that the desired number of containers are running at all times in a replication group. So we have seen different components.
So control manager has node controller that checks that how many nodes are there. You want to add some more worker nodes there, and or you want to remove some worker nodes, or some worker nodes are down or up. So that's done by a node controller under control manager inside the master node. And then replication controller is that how many containers are in one worker node, and it's are they replicating their data to their passive or standby containers in the other worker node. So that's replication controller. If the replication is going on fine between the containers across the node, while node controller just checks that how many nodes are there, how many is there some node being added, is there some node missing. So that is done by this control manager under master node.
Ensures that the desired number of containers are running at all times in a replication group. So we have seen different components like the different offices, the different ships, the data store, the cranes, but how do these communicate with each other? How does one office reach the other office, and who manages them all at a high level? The Kube API server is the primary management component of Kubernetes. The Kube API server is responsible for orchestrating all operations within the cluster. It exposes the Kubernetes API, which is used by external users to perform management operations on the cluster, as well as the various controllers to monitor the state of the cluster and make necessary changes as required, and by the worker nodes to communicate with the server.
So Kube API is then the go-to guy here who is controlling whatever's going on between that etcd cluster and scheduler and control manager and all the external people who are connecting to these apps which are on top of the containers. So Kube API is really trying to run the whole show here. Oh, what happened?
Containers are everywhere. So we need everything to be container compatible. Our applications are in the form of containers. The different components that form the entire management system on the master node could be hosted in the form of containers. The DNS service, networking solution can all be deployed in the form of containers. So we need the software that can run containers, and that's the container runtime engine, a popular one being Docker. So we need Docker or its supported equivalent installed on all the nodes in the cluster, including the master nodes, if you wish to host the control plane components as containers. Now, it doesn't always have to be Docker. Kubernetes supports other runtime engines as well, like Containerd or Rocket. Let us now turn our focus onto the cargo ships. Now,
so all the worker nodes will have the Docker software already installed there, and also the Docker software can be there in the master node, but worker nodes normally have the Docker software, and obviously you know what that software does. it hosts containers.
Every ship has a captain. The captain is responsible for managing all activities on these ships. The captain is responsible for liaising with the master ships, starting with letting the master ship know that they are interested in joining the group, receiving information about the containers to be loaded on the ship, and loading the appropriate containers as required, sending reports back to the master about the status of this ship and the status of the containers on the ship, etc. Now, the captain of the ship is the kubelet in Kubernetes. A kubelet is an agent that runs on each node in a cluster. It listens for instructions from the kube API server and deploys or destroys containers on the nodes as required. The kube API server periodically fetches status reports from the kubelet to monitor the status of nodes and containers on them. The kubelet was more of a captain on the ship that manages containers on the ship, but the applications running on the worker nodes need to be able to communicate with each other.
So first of all, kubelet communicates through the on behalf of worker nodes with kube API. Kube API server can send the command, hey, delete some of the containers there. So kubelet says yes sir, and it deletes the containers. So it's that captain of every node, and those nodes are in worker nodes are in cluster, so they're clustered, right? One node goes down, the other nodes can have a copy of those clusters, so they are all in one cluster that Kubernetes is really handling. So kubelet just works on behalf of the worker nodes.
Example, you might have a web server running in or destroys containers on the nodes as required. The kube API server periodically fetches status reports from the kubelet to monitor the status of nodes and containers on them. The kubelet was more of a captain on the ship that manages containers on the ship, but the applications running on the worker nodes need to be able to communicate with each other. For example, you might have a web server running in one container on one of the nodes and a database server running on another container on another node. How would the web server reach the database server on the other node? Communication between worker nodes are enabled by another component that runs on the worker node known as the kube proxy server.
So kube proxy server does what? If you have a web application here, web application here, and you have a SQL application here. So how can the web application? So all the people are connecting to the web application, and whatever data is being changed or saved needs to be saved in this other container. So kube proxy is the one that lets the applications across different containers talk to each other and communicate with each other, right? So that's what it's saying.
The kube proxy service ensures that the necessary rules are in place on the worker nodes to allow the containers running on them to reach each other. So, to summarize, we have master and worker nodes. On the master, we have the etcd cluster, which stores information about the cluster.
Stores information about the cluster. Cluster of what? The worker nodes.
We have the kube scheduler that is responsible for scheduling applications.
It schedules applications.
For containers on nodes, we have different controllers that take care of different functions, like the node controller, replication controller, etc. We have the kube API server that is responsible for orchestrating all operations within the cluster. On the worker node, we have the kubelet that listens for instructions from the kube API server and manages containers, and the kube proxy that helps in enabling communication between services within the cluster. So that's a high-level overview of.
Now, if I ask you, did you get it? So, overall idea, right? So this is overall idea that if you have thousands of containers, so that's it. This is the master node, and these are the worker nodes here, and then you have to go for. There are these components there for the master node. Overall master node is controlling the whole environment, and worker nodes are hosting the containers that kubelet is taking all the orders from kube API server within master node, and kube proxy is letting all the applications talk to each other. within the worker nodes, and worker nodes are in a cluster. So well, that's the overall view of Kubernetes here, that how yeah, they are really organized, and how we can work on it. So yeah, after the break we'll go for the Kubernetes lab, and let's check out that. Okay, so let's take a break and let's come back. Okay, so we talked about Kubernetes, and well, there are so many others. If you just go to YouTube and type Kubernetes for beginners, so there's a long list of people who have talked about Kubernetes and their structure, its structure here. So what we're going to do is we will go to the command prompt, and we're going to go for Google Cloud Shell for that. Start recording. Yeah, it's recording. Okay. So here, so let's open GCP Cloud Shell, and then let's give some commands. So different project, follow this. Well, yeah, this is also another that's it. So website where some of the commands are there. So if we go git clone, samples are there, cd Kubernetes engine samples. So first you create a folder there, and then you go inside that folder. Then there is in the project you try to create an application, and so you first try to go for Docker push. So I'm just gonna go for this console.cloud.myproject. Now this is my yeah, this link that I shared with you, right? So because of its popularity and widespread adoption, Kubernetes has become the industry's de facto for deploying a containerized app. Google Kubernetes Engine GKE is Google Cloud Products GCP Managed Kubernetes Service. State-of-the-art Kubernetes in the cloud. So each of the major cloud providers have a managed Kubernetes service, also known as Kubernetes as a service, which creates an isolated and supervised environment for Kubernetes clusters. These services provide the Kubernetes API. So each of the major cloud providers, these are AWS, Azure, okay, GCP and Azure, they all provided that. And CLI environment setup. So first step in deploying a containerized app is getting a CLI environment in GCP. We will use Cloud Shell to do this, since it already has installed and configured gcloud, Docker, and kubectl. Cloud Shell will enable you to quickly start using CLI tools with authentication. So we start a terminal here now, and then microservices to containers, which is okay. Before that, I'll just check out one more thing. Authorized container registry. Okay, so what's going on here? What is container registry? We're gonna talk about that as well. And the container registry normally has images. So first of all, what is container registry? Container registry is just like in Azure, there was a container registry. It was ACR. So Google Cloud also has container registry. So it is a repository of images, right? So images. It has a repository of images, and uh, so and in that we have to upload. We can upload containerized images to the registry and download from there as well, right? So we can do this containerized upload and download of images. So that is container registry, and once you upload the image, then you can download the image to where? Now that image would be downloaded in Kubernetes, and Kubernetes will, what will be that image? That image will be one application that gets downloaded, right? So registry first you upload an image to the Google registry, then you download from there. Suppose that's an image for containerized SQL Server, right? So you would just download that image of SQL Server, and you would just put it in the containers, which is being handled by Kubernetes. So that's where container registry comes. This is pretty much same story that we went through in Azure as well. Azure registry is there, and Azure Kubernetes was there as well. So now this site, just this guy here, he takes us towards deploying a container image, and then deploying it in the project, and then letting Kubernetes really handle that image, right? So that's overall what we get to do. And what is Kubernetes? Kubernetes engine is separately available. So if I go there to this navigation menu, so this is the Kubernetes engine, right? So, and there are clusters, workloads, and service and ingress. So this is where you can create a full Kubernetes engine, right? So we're gonna do that, but first I'm just gonna go back here to this guy. So Kubernetes originated in Google, and its provider, cloud provider Gcp, has the most convenient and easy setup for creating new clusters. So before that, what he did is the following steps will guide you through creating a Docker container for Hello app and uploading the container image to the registry. When you deploy the application, Kubernetes will download and run it from the registry. Now, whenever you hear the word registry and related to containers, always think of it as a repository of images. So it's just a folder where you upload images, and from where you can download images, right? So that would be the registry here. Now what I want to check here is that one way is that I have gone through testing these commands to really upload an image, and then I have gone to some other commands there as well to upload images. There are so many types of commands there where we can. So first of all, gcloud with configure Docker. So first you get authentication, gcloud auth. Hey, can I upload an image? For that you need to run a command, gcloud auth configure Docker. And then if we go to the registry, which is a separate area here, that would just be empty, obviously, unless you upload an image and then download it into Kubernetes. So the plan here is, if I go back here to the diagram, is to upload and a containerized image in GCP registry. Then second thing is create a Kubernetes cluster and deploy / download this containerized image, right? So the main thing is how to create a Kubernetes cluster, and some of the components that we can see there are going to be shown there. Obviously, after that, once you do an initial deployment and configuration, even that is tricky. But after that, obviously, it's then you have to run some codes there to really maintain the whole environment. There are many components, and you saw those components, so it becomes really complicated after that. The more you take interest, you can just jump into it. But there's a lot of developer stuff. So if you're a programmer, you will be very much interested in this. So if I go back to this diagram, so here it is, first of all, we're making this registry available, and I'm going to go directly to the registry, and I'm going to enable some services in the registry, and then I will go for pushing or uploading an image to the registry, right? So this is and what is the image that I'm gonna upload? I'm gonna go for Nginx image from docker.com, right? So I will be putting that image up in the registry. Then I will be downloading that image from the registry. So registry is just a repository, right? So after that, I will just go for it pushed to the GCR yay. So the first thing is, are we able to upload an image from the hub.docker.com to the registry, which is just a folder or repository where you can gather images. So once that is done, then pushing a Docker image to Google Container Registry. Okay, there are some videos for that too, but it's a portion of this video helped and portion of that video helped, and then a lot of Google groups helped as well. So it's a lot of research and test and trial, and then I get to do everything. Let's deploy a containerized app now. So first we upload that image to the registry, then we download that to the Kubernetes engine as a workload. So when we deploy a workload, so we have to just define that what image you want to deploy. Now, why have I gone to workload? Did we create a Kubernetes engine? So that's the thing. We have to first we upload the image to the registry, and then we come here, we create a Kubernetes cluster. After creating a Kubernetes cluster, we deploy that image from registry onto the cluster, right? So those are the major steps there, but normally it's not that really straightforward, all of this. But if you have uploaded an image to the registry successfully, then Kubernetes cluster will be easily able to detect it from the registry. If you were not able to upload the image from the registry, then there are much longer ways to deploy the image. So, but whatever image we upload in the registry, if we download it on top of the Kubernetes engine, then Kubernetes can make, if there's one container, then you can go for more images there, keep on deploying more containers there, and it will then start doing orchestration. So and these are all the steps there for getting an image and then configuring all the stuff there. It looks like a YAML file there, which we can understand as well in easy language. So it creates how many parts? It creates 3 parts there, which are actually 3 nodes, we can say as well. And so we're going to see all that getting created when we are deploying the workload. So again, I'm going to go to the first stage there, where we are deploying that image. So now what was that site here? Yeah. So here, when you deploy the application, Kubernetes will download and run this, run it from the registry. Now this guy has gone for a hello app, and that hello app, this guy is saying that he pushed it to the registry, and then he created the Kubernetes cluster, and then he downloaded that. So this is something that I tried first, but then I went for the rest of the lab. So uploading image to registry, this is where we actually start. So first thing is, it is a repository of images. We can upload containerized images to the registry and download from there as well. So I'm going to go for, first of all, I'm going to go to Cloud Shell quickly. So I'll go to close this, and there's a Cloud Shell here. So upload the image registry, create a Kubernetes cluster, and deploy that image as a workload on the cluster. That's the main objective here, right? So I have gone to the Cloud Shell. It is now ready. I'll just try to put one more thing I need to show here is if I go to search and I type here registry, there's a container registry here, right? If I type in search registry, there's a container registry. So I'm just going to click that registry. Now GUI, whatever you do, it separately works, and here it separately works. Now once I go to the registry, it says that enable container registry API. So obviously, just like for VPC, when we go there the first time, it enables the Compute Engine API. So here it's container registry API, it needs to enable that. Container registry API not enabled. So I'm just going to click that, so to interact with container registry. Otherwise we won't be able to upload an image. Okay, that's one thing. And second thing is, I'm going to go for settings and enable vulnerability scanning. So I'm going to click that too. It's just going to enable scanning, vulnerability scanning, but if we don't do that, then it doesn't let us go ahead with uploading an image to the registry as well, even in that case. So I've done these two things, enable API and enable vulnerability scanning. Now I'm just gonna go up there, and I'll just go for the first command, which is this. So G cloud auth configure dash docker, right? And so this is the first command here, that this is just to get authorization. So contains these credentials, credential help, gcloud. So this is just Cloud Shell, and then authorization, authorization of Docker to work within Cloud Shell. Okay, so I'm gonna go ahead and quickly so I'll put that here, and I'll go for that authorization. And adding credentials for all GCR repositories, long list of credential helpers, because okay. So first thing is that, and then the second thing we'll go for is, yeah, the history. I already clicked it, pulled it. So enable vulnerability, yeah, gcloud auth configure docker before pulling image from hub.docker.com. Please create a free account there. Now guys, I need to pull an image from the Docker, and then I need to push it to the registry. So how does it work? If I go back to this screen here, so all the images are there, hub.docker.com, right? And I need to pull an image, nginx image, down from there, and once I pull it down in Cloud Shell, then I need to upload it, which is, so this is pull, and this would be push. Push where? Push to GCP Registry, right? Push to GCP Registry. So now, do we have a free account? So normally it does ask that please create a free account here in hub.docker.com, and well, docker.com, right? So that would be that is something that it's going to ask you to log in from Docker to pull an image from there, right? So it's just a free account that you should be creating there. Okay, so I'm just going to go there and first try to pull the image if it accepts that without me creating an account. Otherwise, you can see the screenshot here, Docker login. I had to log in and give my username, password, and then I was able to give the pull command, docker pull nginx, right? So first I'm going to go for docker pull nginx without actually giving the login credentials of the Docker, which are just free, right? You can just go ahead and create that. I'm going to go to Cloud Shell here and go to Docker. First of all, just type Docker here. Is Docker commands available there? Yes, all the Docker commands are available. Second thing is that I'll go for Docker pull nginx. So it's gonna go to hub.docker.com and it's gonna try to download from there the nginx container. Nginx is web server that is containerized. So if I press enter, okay, so it's downloaded. Otherwise, sometimes if it asks for, hey, you're not authorized, so in that case you have to go there and create an account. You know that it's better to create a docker.com free account as soon as possible, or whenever you can. Just create that. It's going to be useful in future. So once logged in from docker.com with my ID, then I'm able to pull that image. Yes, it just put that restriction. That's why I then had to go for it. Right now it just downloaded it. So if I go for Docker images, so there's that other command, Docker images, right? So it shows this nginx latest and image ID here 2 weeks ago. It was uploaded there on Docker image ls. If I go for, so Docker image ls actually shows me the repository image ls, right? It shows me that or it's supposed to show me that repository address that I needed to use there. So like it is showing here, Docker image ls. Oh, okay, sorry. Before that, we need to tag the Docker. I missed this one. So this one, sorry. So tag just tags it. Hey, are you ready? Tag just gives it a long URL that can be used to push or pull that image. Normally you need to push it towards the registry. So for that you need to run this docker tag command. Now this is a full command that needs to be run, but obviously with the correct project name here. So I'm going to go for my project name here. This is the project. I'll go here and I'll try to grab this and somewhere else, and instead of this project, oh, what happened? Serious? Okay, let me just go for removing its format by going to okay, and oh no, I need to copy that project name again. So docker tag just makes it ready to be pushed up to the registry. So docker tag. Oh, seriously, docker tag. I don't think it's sudo I need, but no, docker. Okay, am I making any mistake? Let's tag the image. So first, the image is there. Yes, the image is there. Second thing, docker tag nginx. Nginx. Okay, let me check my image name that is there. D should be D. Oh, small d. Okay. Alright, thank you, Manu. So docker tag. Wow. Okay. Thank you. And how come? Oh, because it was the first letter, it made it big D. So all these D's are. Thank you for noticing that. Okay, so now docker image ls. When I go for that, docker image ls. So it should have that. Yes, it has that URL. Actually, not seriously. It's not a URL. It's the repository address that will help us push this image up in the registry. So docker push is the next command, and obviously I need to still change the project ID. So, oh, serious. Okay. Okay, so we have to push that image up in the registry, and then it says, oh, are you authorizing that? So I'll say, yeah, go ahead, please. Okay, so it's preparing, layer already exists, and then it shows that this is done. So it's uploaded to the registry, is it? So yes, okay, authorize was there. And well, you refresh that and it should be in the registry, which was showing empty, should now show that image. It's showing empty here. I'll refresh that now. Now that image is there. Okay, so its first stage is done. That we need to download from hub.docker.com an image and containerized image, and then upload it to the registry. So what's the big deal with that? So now we should be able to deploy first the Kubernetes, and then we're going to deploy this image to that Kubernetes as a workload on top of it. So for that, I'm going to go and head. Containerized app. Now I created the whole Kubernetes, and I'm not sure how come I missed that those screenshots for creating Kubernetes, although it's a pretty straightforward process of creating it. Nginx actually on top of Kubernetes in fact worked. It opened as a web server. So I'm just gonna first of all go to the Kubernetes engine and simply deploy the Kubernetes cluster. Next, finish, right? And then I'll go for the main task. Actually starts from here, where on top of the Kubernetes you need to deploy Nginx image as a workload, right, on 3 parts of Kubernetes. So I'm gonna go here and right click here, go to duplicate, and here I'll go to navigation menu and go to Kubernetes engine. Oops, not compute engine, seriously. Wow, this time I did not click right away. So there's a Kubernetes engine and it says, hey, you want to create one? So I'll say, yeah. Okay, I'll click the create cluster. Well, it's still loading. So I'll go for create cluster. So it says cluster 1, and then do you want to go zonal or regional? So I'll go for on the zone level, and it is US East 1 B. I'll go for US East 1B, and then static version of this Kubernetes. Yes, this is the version of the Kubernetes. So not much here, pretty straightforward everything. So I'm gonna not go cross region here, it's gonna cost more. I'll just stick to zonal or within the region. So I'm gonna click create here. So then Kubernetes cluster initially basically starts getting created. And it says total cores 3, cluster sizes 3, worker nodes. Well, it's gonna get created. No, I always take screenshots, but that's pretty strange. Although there was not much in the screenshots. It's the workloads that is the main task. Because when we were creating Kubernetes cluster, so it was pretty much so it did not ask a lot of stuff. So it does create 3 nodes there, and once it is created, then we're going to click the connect button. Yeah, it also shows that on this. So this guy also just deployed that uploaded image to the inventory here down to this, and so it opened as hello world. Okay. Well, it's still getting created. So I did, when I was doing the lab, I did lose the connection to this Cloud Shell, or it expired because of no activity. Then when I tried to access that registry image, so it says, hey, where is your hub.docker.com account. So at that time when I got disconnected and I got reconnected to this, then it did not let me download or connect to that image. Well, at that time I hadn't downloaded it, but I went somewhere and then I had to come back here and then checked it out. So it asked me hub.docker.com. So that's what I'm saying, when you're doing the lab, go ahead and create a hub.docker.com free account anyway. You will need it in future. Okay, it's created, and if I click the connect button, so it shows there you can connect to your cluster via command line, run a Cloud Shell, or Cloud Console dashboard, open workloads dashboard. Yeah, I know. Well, we can connect these this way to the. If you command the command line, you can just go for kubectl command. So just like Docker, when you install, so it goes for Docker run, Docker info, Docker ps. So all these commands start with Docker. So here, for Kubernetes, the command starts with kubectl, and then kubectl whatever else you want to run. If you want to go command prompt, so I'm just going to press OK here. It says there that hey, you want to actually deploy that. So if I go inside the cluster here, so details are here, then nodes. So it has actually created 3 nodes, 349 mCPU, micro CPU here, and 2.79 GB memory per node allocated here. So you got 3 worker nodes here and 3 containers. Well, overall 3 copies of that. Three worker nodes are there. Container we are about to deploy now, right? So I'm going to go ahead and go back to, well, this is the cluster, but I want to go to the workload, because the cluster is no good if there is nothing on top of it, right? So I'm going to go for workload. I'm going to click deploy, and with deploy, so it says that, hey, what do you want to deploy? Do you have an image already? Do you want to have you want to download somewhere else new container image, or do you have an existing? So yes, we actually do have an existing container image here, right? This Nginx that we deployed from the, see this, Google Container Registry. So enter your image path or choose from Google Container Registry. So if I click the select here, so it shows up that, hey, this is the image that you have. Remember that we just pushed it just now in the registry, so it shows up here. So I'm just going to select that image, and I'll expand that, and then select actually this ID of the image, containerized image, that is for Nginx, which is the web server, and I'll click select. Okay, so the container image is selected, and then there is environmental variables. If I go for add environmental variables, so it's just key value that you can add, department, this, manager John, or whatever other metadata you want to add, or some commands you want to give to the image. I'm going to click done here, that hey, this is the application and the containerized image that I want to deploy on top of the Kubernetes, and then I'll click continue. And then it says configuration. So what do you want to name it? Okay, Nginx 1 is okay. Key value pair is app. Is it an app? Yes, it's an application. What is the name of the application? Oh, it is Nginx 1. So we're just giving some key value information in the form of key value. So at Kubernetes label, you just want to add some more labels there. View YAML file. So whatever you're about to do here, if you're going to see that in YAML format, so, or how in the background the codes are written for whatever you're about to do. So this is that in YAML format, the whole code that's going to be run in the background. If I click close here, then yes, this is the cluster name, and there is that create new cluster. I'm gonna check that if I'm not missing anything, although I do not think that I am missing something. but I'll just be really, yeah, okay, what else? Okay, the main thing is, okay, we're gonna expose this once it is deployed, that's it. So we're just gonna deploy that because there is no other option here. And I was thinking, so I'm gonna click deploy. So what we're doing is, so first we downloaded from hub.docker.com a containerized image of a web server, Linux web server. We uploaded it to the Google Registry. Then we created a Kubernetes cluster and 3 nodes. And those 3 nodes are saying, hey, what do I do? And then you say that, okay, I'm arranging Nginx containerized image on top of you 3 nodes. So now to let others access your deployment, expose it to create a service. So we need to create a service that will help others to access this Nginx web server. So I'm going to click that expose. Well, this is just some by design that you have to click that. Once you click expose, then it says that, okay, how do you plan to connect to this web server? Obviously port 80, right? And do you want to load balance this 3 parts there? Because this application is deployed on all 3 nodes there. So, and what was the service name? So this is the service name. Okay, we want to view the YAML file or the code form of it, what you're doing here, so you can view the YAML file. I'm going to click expose here. So what we're expecting is that this application is being deployed on Kubernetes cluster. Kubernetes cluster, when it was created, it created 3 nodes. On 3 nodes, this containerized image is being deployed on all 3 nodes, and it's going to be load balanced, right? So now once it is deployed, there's details here, and cluster 1 and 3 pods are there, 1 pod, 1 node, right? And there you can see the cluster IP, public IP here, right? Oh, well, that's a private IP, sorry, this is the public IP here, and that's a load balancer ID. I can right click and copy the public IP here and put it up there. Yay, it works. So it lets us connect to an application that is a containerized image of a web server. That is the first page of that web server that is deployed on top of 3 nodes, and these 3 nodes are being handled by the Kubernetes right now in the background. So you can add more nodes there. Then you want to play with the cluster, you want to add more applications, and you want to make changes, you want to play with the whole infrastructure, you can go ahead and play with that. But this is the workload or the application containerized image of an application that is being deployed on top of this cluster. So well, that's what I got to do after. That's what I get to do after deploying, going through a lot of different, I had to follow a lot of different people, sites and YouTube just to get ideas from different areas. So it looks like very smooth steps there, but removing all the errors and complications was the main challenge, and it's still the start of it, right? So at least till here, if you understand, then you can just explore all the other features in depth of the Kubernetes engine. But this is the same way you would deploy it on Azure, or this is the same concept of deploying Azure-based Kubernetes and AWS-based Kubernetes, that you just need to upload an image to the AWS registry, Azure registry, GCP registry, which is just a repository of images, and then first create the Kubernetes cluster, AWS Kubernetes cluster, Azure and GCP Kubernetes cluster. Then you simply deploy a workload on all 3 clouds. It works the same way. How to remove one node? Okay, so well, that's then all the okay, there's a cluster here. Then yeah, we can come up with add node pool is here. So this is a node pool. First of all, it's a pool of node there, right? So there's one node, second node, third node. It is clickable. The main thing is if they allow us to delete, yes, we can delete. I am inside one node, and from there you want to go for kubectl commands there, or you want to cordon node details. This is the pause button here, and cordoned node. So this is node has been cordoned and does not accept new pods. So this is just you have paused the node because the pause button was there. If you go for uncordoned, so it is so you want to pause that. That much you can do, but you want to delete the node. Then obviously if there's that node pool that can be deleted, and another node pool minimum 3 can be added here. If I go for node pool delete, so there's a delete data in the host path and empty dir storage pods will be deleted. Any running containers will be also deleted. You want to delete cluster. This is the whole cluster that can be deleted with whatever nodes. Default pool is this, and there's a this bucket. Are you sure you want to delete default pool? So pool has minimum 3 nodes here. So you can get rid of this pool and create another node pool, right? And you can duplicate that node pool as well. Yeah. Okay. So there you go. So guys, this much there is, and now, well, tomorrow we're gonna go for, yeah, we can delete the whole pool. Yes, gentlemen. So tomorrow we're gonna go for databases, which may not be a very long topic, and we're gonna start with the Oracle. And guys, this week I will try to take all the days, like tomorrow, the day after tomorrow, to finish as much of Oracle, because next week I can give only time to on Friday. So it's a really busy week going on. So I had to prepare for these labs, so that got all my time, plus other projects going on, so it's not that easy to create labs that really clarify the idea. So okay guys, tomorrow I'm gonna try to go for tomorrow as well and try to finish the database and then start the Oracle Cloud. And what I was planning was that this week I should finish Oracle Cloud as well and the whole course. But if something is left, then from next week onwards it's gonna be just Friday. Only Friday I will be able to give. Okay guys, so see you, and I'll delete this now, and please do repeat all these labs and explore, right? Alright, good night. Thank you. Night. Alright, thank you. Night.